Hey everybody, today we are going to look at classifying 3D figures. Hopefully this is a review from elementary school maybe, to just go back over the shapes and make sure that we have all of our vocabulary and our terminology right so that we can move forward next week and the week after with finding surface area and volume of these shapes. Okay, so I've attached this in the Google Drive or the Google Classroom. If you want to print a copy of this out, you can, or you can write down what you will. You don't necessarily have to draw the pictures because this is not art class. We do not need to go there. Okay, do the best you can. All right, so first we have our two basic shapes. We have a prism and a pyramid. Okay, so on a prism, it's going to be a solid and it has these two bases that are congruent and parallel to each other. So this triangle here and this triangle here are congruent. They're exactly the same size, and if I put my hands on them, they would be parallel to each other, kind of like the top and the bottom of that. Okay, so this figure here is called a triangular prism because it has two triangular bases that are congruent and parallel to each other. Okay, over here we have our pyramid. A pyramid is a solid that only has one base. So this is going to be its base, okay, and all of these faces that come around on the edges, they all meet at this one point up here at the top, which is called the apex, okay, like the top of the mountain, okay. The apex is that point where they all come together, okay, and so the easiest thing on a pyramid is to find that apex, and then the side opposite from that, if you put the apex up at the top, the side down there on the bottom would be the base for that. Okay, now the problem is that that doesn't always work for the prism. Okay, so the prism is not always, or the base of the prism is not always what it's sitting on, and that's where people tend to get confused. Okay, so I'm just going to show you a couple of examples. So here I have a pyramid. Okay, and so this point obviously is the apex, right? All of these triangles come up to this top. So the base is going to be down here across from that apex. So if I twist this so that you can see that base, this base has 5 sides. So this is a pentagonal pyramid. It has a pentagon as the base, and then it's a pyramid. Okay, and so what you would notice is if I pull this out and I open this up, this is called the net of our 3D figure. If I open this up, you're going to see the one pentagon, that's the base. And then when I open up the rest of this, you're going to see triangles that go around all of those other faces. And notice that there are 5 triangles here to match the 5 sides of our pentagon. If we didn't have 5 sides there, 5 triangles, then this pyramid wouldn't be closed up. It would have like a hole or gaping opening in it, okay, which we don't want. Okay, so usually when we see pyramids, they are sitting on the base. It's not very often that we're going to see a pyramid like drawn like this. That's just kind of weird. Every now and then, if we're talking about composite figures, we might see a pyramid hooked up to a prism kind of like this, so it might be sitting on its side, but usually it would be standing up, so it would kind of be like a castle or something. Okay, so if I look at this pyramid, or the prism, sorry, that goes with our pentagon, okay, now this is the one that could be sitting like this, kind of looking more like a house, right? So this is the end of our house here, and then it's sitting on this base down here. So what happens is if I pick this up and I look at the base, what shape is that? That's a rectangle. So would you call this a rectangular prism? No, that would be crazy, right? So the bases on our prism are the two faces that are congruent, exactly the same size, and are parallel to each other. So what I do is I like to think of it like I'm picking up my shape. If I were to put my hands on those two ends, and my hands are now parallel, okay, to each other, these two ends are going to be the bases, and they're going to be the same shape, whatever that is. Okay, so this is a pentagon, and then notice that all around through the middle here, these are all rectangles. Okay, every prism is going to have two of whatever base you have, whatever shape is on the end, and then all the way through the middle forming that prism is going to be rectangles. Okay, so if I open this up, okay, I've got my two pentagons that are my two bases, and then if I open this middle up, okay, these are all of my rectangles that form like the center. Like if you think of it like a soda can, right? You have your top and your bottom, and then this would be like where you hold your hand, okay, and that part is all the rectangles. Okay, all right, so let's look at the one that is the most difficult for us to deal with, and that is this thing. Okay, this is the one that gives people the most trouble when they're working problems for finding surface area and volume. Okay, because typically this shape sits like this. Okay, sorry babe, I can't help you. Try plugging it back in or something. I'm in the middle of something. Sorry y'all, iPad crisis. Okay, so when we talk about our shape here, it tends to sit on this side. So again, if you go with the idea of the base is always on the bottom, which I'm sure somebody told you along the way because it made sense for whatever you were doing at the time, okay, the problem is the base is not always the bottom. If we take that idea and I pick this up and I look at the bottom, this bottom is a square or a rectangle depending on whether they're congruent or not. Okay, so would you call this a square or rectangular prism? Does this look like a square or rectangular prism? Please say no. Please say no. It has these triangles on the edge. Two triangles on the ends. These two triangles are parallel and congruent to each other, which means those triangles are going to be the bases. Okay, and we have all these rectangles here through the middle, so this shape is a triangular prism. Two triangles on either end and rectangles all the way through the middle. Okay, triangles on the end, and then all of our rectangles through the middle. Okay, so today we're just focusing on naming the shape. The other thing that we're going to review are what we call faces, edges, and vertices. Okay, so the faces are each one of these. This is a face, this is a face, 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 right? So all of the sides of our 3D shape. So this shape here has 5 faces, has the 2 ends, and then it has 3 rectangles through the middle. Okay, these are the edges. So if I was to draw this, I would draw 1, 2, 3 sides of this triangle. I would draw 1, 2, 3 sides of this triangle, and then I would draw these 3 lines in the middle to connect the 2 triangles to each other. So 3 plus 3 plus 3 makes 9 edges that we would need to make this shape. Okay, and then the vertices are these corners where I'm holding my hands right now. So I have 3 corners on this end, 1, 2, 3, and I have 3 corners on this end, 1, 2, 3. So that makes 6 vertices. Those are our corners. Okay, so we're going to review that as well. Okay, so pyramids all come up to a point, lots of triangles there through the middle, and then those are pretty easy. I'm not really worried about that. And then we have our 3 round shapes. When we talk about the round shapes, we don't talk about edges, faces, and vertices, except the cone has a vertex. It has a point up there or an apex. But other than that, we don't really talk about faces and sides because they are all round. Okay, so on our cylinder, we're going to have the 2 circular bases, and then when I open up the middle of this cylinder, all of this stuff here, which would be like where the label on our can is, right? Like if it was a can of green beans or something. Okay, notice that this makes a rectangle here through the middle. So 2 circles with a rectangle that kind of wraps around and meets up with those circles. That makes it a cylinder. Our cone comes to a point. A cone can be a little misleading. Some people think that a cone is a circle and a triangle, but when I actually open up the lateral parts of this cone, this is more of a sector, like a section of a circle, as opposed to a triangle. But it has 1 base, and it comes up to that point. And then I don't have an example of a sphere in my hand, but that would be, you know, basketball, baseball, whatever. It's all round, has a center. It's all the points that are the same distance from that center point. So you're going to see that center in your sphere. Okay. All right. So let's go through a couple of examples. So the directions say classify each solid, so we're going to tell what its name is. We're going to highlight or color in the bases, and then I also want to do faces, edges, and vertices for each one. And so we'll write that as F, E, and V for the other ones. All right, so what shape do we have here? So the question is it a prism, pyramid, cylinder, cone, or sphere? So is it round? It's one of these. If it is not round, it's going to be one of these two. So this does not have any round pieces. So is number 1 going to be a prism or a pyramid? Okay. This comes up to a single point. So this makes this a pyramid. So we're going to name what shape the base is in front of that. So this is some sort of pyramid. So across from the apex is what shape? What shape is this? Okay, now when you name the shape, think that you are looking straight down on it. What shape would that be? That would be a rectangle. So this is a rectangular pyramid. Okay, so the faces, this base is 1, and then how many triangles do we have around the middle here? 4. 1 for each side. 1, 2, 3, 4, plus the base makes 5 faces. If I trace the edges, 1, 2, 3, 4 for the rectangle, and then I'm going to have 4 lines or edges that come up to that point. So 4 plus 4 makes 8. And vertices, I've got 4 corners down here on the bottom, plus this one up at the top. So that makes 5. Okay. Every rectangular pyramid is the same faces, edges, and vertices. Okay, that part won't change. All right, what shape is this? Okay, the base is right here, the circle. Okay, and this comes to a point, so we call this a cone. It does not have faces, edges, or vertices. Don't have to worry about that. Okay. All right. Number 3. Is this a prism or a pyramid? Does this come to one point? No. This is a prism. So where are the 2 congruent faces? A little triangle. So this is a triangular prism. Triangles are the bases, because those are the 2 congruent parallel pieces, and then we have rectangles here through the middle. So faces, I've got the 2 bases, plus the 3 around the middle, 1 for each side, 3 rectangles. So 2 plus 3 makes 5 faces, top, bottom, and then 3 for the middle. Edges, I've got 3 along my triangle, 3 along this triangle, and 3 connecting. 3 plus 3 plus 3 makes 9 total edges. And then our vertices are the corners. So we've got 3 on this triangle and 3 on this triangle. So that makes 6. Alright, let's see. What's this? Prism or a pyramid? Point up here. Pyramid. Where is the base of this pyramid? If the apex is here, then the base is across from it. So what shape is that? 1, 2, 3, 4, 5, 6. A 6-sided shape is called a hexagon. So we write the word hexagon and then we put A-L after it. Hexagonal or hexagonal, either tomato, tomato. Okay. Hexagonal, hexagonal. All right, faces, edges, vertices. Faces, so we've got the 1 base, and then how many triangles do we have around the middle here? 1 for each side of our hexagon, so that would be 6 more. 1 and 6 makes 7. Edges, 6 sides down here on our hexagon, and 6 edges coming up to the point. 6 and 6 makes 12. And our vertices, we're going to have 6 corners down here around our hexagon, and then the 1 up at the top. 6 plus 1 makes 7. All right, what shape is this? Yeah. Cylinder. It has circles as bases, no matter which way it's sitting. Every now and then you'll see that cylinder kind of turned on its side like this. Okay, the bases are still the circles because they're still the parallel congruent pieces. Okay. All right, this is a rectangular prism. It actually has several different faces that you could use as the base. Like we could use these 2 little squares as the bases because they are parallel and congruent to each other. We could use the top and the bottom if we wanted to. They are parallel and congruent, or we could use kind of this front and the back piece. Okay, any 2 sides, any opposite sides of our rectangular prism could be used as the base. Doesn't really matter in our work that we're doing. Okay. So faces, so we've got the 2 ends, and then we've got 4 rectangles through the middle, so 2 and 4 make 6. Edges, we've got 4 edges on this end, we've got 4 edges on this end, and 4 through the middle, 4, 8, 12. And vertices, 4 corners here, 4 corners here, makes 8. Okay. All right, so I'm going to lay off of the face, edge, and vertice thing. Let's just go ahead and look at these last couple pictures and get our names for them, and then we will be done for today. Okay. All right, so actually what I'd like you to do is I would like you to pause the video and name these last 6, and then turn the video back on, and I will go through the names of them really quick. Okay, so you're on your honor. Do it. No, now pause, write down the names. All right, so I'm going to take your word that you paused, okay, and that you got not a rectangular prism for number 7, even though it's sitting on a rectangle. That is not congruent to this piece up here at the top. Those are different sizes. So this shape here on the end is going to be our base. And what do we call that shape? That is a trapezoid. So trapezoidal. And is this a pyramid or a prism? Prism, because it has 2 bases that are opposite and parallel to each other. Okay. All right, 8. This is a pyramid because it comes up to the top. What shape is this down here? This is a rectangle. You may have put square. I can't really tell from these little tick marks if those are all the same. Rectangular pyramid. It could be a square pyramid if all 4 of those sides were exactly the same thing. Okay. All right, number 9. Let's see. What is that? 5 sides, pentagon, pentagonal prism. Okay, remember pyramid always comes to a point. Prism has those flat top and bottom. Okay. 10. That is a triangular pyramid. Comes to a point up there, apex. 11. Okay. Not what it's sitting on. This is not a rectangular anything. Okay. What are the 2 pieces that are parallel and congruent? This and this, which are triangles. Triangular prism. Okay, make a note here. Base is not always on the bottom. Okay, sometimes your bases are on the sides. Okay, and last one, 12, sphere, sapphire. Okay. All right, go. Love you, bye.